Alright, just wanted to show you here, I got the low amperage output of the Raspberry Pi GPIO pins powering through this little, what is that, that's a 22K resistor. Sorry, it's been a while. And then basically I got a pull-up resistor of 100K there holding the top of the transistor up, and then this is the control for the optocoupler that's controlling the light. So, and then of course the bottom pin is grounded. I can't remember the names of the transistor pins. Anyway, I guess it's not important right now. So, basically this is just to convert from the 3.3 volts to the 5 volts that I need for the optocoupler. And that's all that really is. Basically, you may be wondering about the crazy ribbon cable setup. I didn't have any good way to get to the pins without accidentally shorting to the other pins. So I happened to have the spacings on that ribbon cable connector were correct, so I could just plug it in, and then I just basically split out the wires and tinned the ends and hooked them up. So I got the 5 volts from the board coming here powering this, ground from the board coming here powering this, or grounding it, and then I got pin 18, or the GPIO pin 18. It's actually pin 12 coming from the Raspberry Pi over here, controlling the transistor for the 5 volts. So anyway, that's kind of the setup I have there. And then, alright, so we're going to come over here, and so this is just a little script I wrote in Python, and I'll show you the code for it here in a second. But basically I can just type let's make that an O. It's kind of hard to type and hold the camera. O FF, and if I do that, so I just type that and I hit off, and the light has gone off. So I come back and I type O N, bam, light comes back on, and that's through being controlled to the optocoupler from the Raspberry Pi. And then I'm going to type exit EX I T, oops. Alright, hold on, I can't type and do this at the same time. Alright, so we're out, and then I'm going to go Vi, and then the name of my program is LL ED E D Pi. So what we got here is just a Python programming. So you're importing the RPI GPIO as GPIO. All that does is tell it to import all the commands for the GPIO pins. There's a library for Raspberry Pi. Set mode GPIO.bcm. The pins can be referred to in a number of ways and for a number of applications. So for example, some maybe transmission pins for serial data or something like that. I just want to use this as a standard GPIO, which is 1 or 0. GPIO set warnings false. It sends out a bunch of warnings to the screen. I'm telling it not to do that. GPIO setup. This is setting pin 18 as a GPIO out. So I'm setting pin 18 up as an output. So that's GPIO pin 18. Again, it's actually pin 12 on the header. It's confusing. I create a variable str state, so it's state string. It's a string variable. So state equals empty. So I'm starting off with the string empty in it. Then I got while true, which is just a loop. It's just saying keep looping this while true. So it's always true, so it's always looping. So it's a never-ending loop. And so while you're doing that, I get input for string state, and then I'm just telling it to accept as a string raw input, which means just take whatever I input and stick it in the string, and don't interpret it as any kind of Python command or anything like that. That's why I use raw underscore input instead of input. And then I just have a little statement in there, enter the light state on or off. And then I've got if string state is in, and so basically what I'm telling it is if it's in this long list of things. So basically I've put every possible thing I could think of you would put to turn someone would type to turn the light on. And the reason for that is because later I plan to switch this to voice for Alexa. And whenever I do that, I want it to be as natural as possible to interpret as many different types of input as possible. But I also included, errors for capitalization and things like that for the typing. So you can type this about as naturally, pretty much anything you can think of. You can type, lowercase on, uppercase on, hi, y, yes, whatever. And then it'll output LED on, and that's just something to let me know it got the message on the computer screen. That way if the light goes out, I won't assume it's a problem with the program or something, And then I just tell it GPIO output 18 GPIO high. So I'm telling it to take 18 high. And then I've got an else if the state is in off, then take it low. It's exactly the same thing, only I'm just telling it take it low. And then if I get an exit, that just tells it to quit the program, right? Exit, quit, stop, whatever. It just quits the program. And then if I get anything that doesn't fall into quitting the program, turning the LED on, turning the LED off, then it gives you an invalid entry error. And then whenever you have a quit, it just prints the str state variable, and that's just to let me know that something was typed that means to quit. And again, that's something I plan to expound on more just later whenever we're actually doing it with voice. And so that's pretty much my setup. Now I can type commands to turn on my light. And so again, that's the first step. All right, bye.